Hello again, everyone. We are back this time with Jay Sharma, and he's going to be talking about the modern experimentation stack, which is lessons learned from his time at Airbnb, Webflow, and now Eppo. Um, Shay was formerly the fourth data scientist at Airbnb and has been an early data scientist at companies like Webflow. He mostly focuses on the maturity curve of growth stage companies and helping to make data essential stakeholder in decision making across the organization. So with that, Jay, I will hand it over to you, and I'll be back in about 24 minutes to help with any Q&A folks have, but I'll let you take it away.
Sounds good. Thank you. And I just noticed we have a similar taste in the shade of green.
Yeah, we have very similar like office settings. It's good.
I know. It's like,
Very matchy matchy.
sweater over there. We'll get you one.
Sweet. Yeah, I would love that.
Cool. All right, let's get started here. So I'm here to talk about experimentation today. Topic near and dear to my heart, and especially around what happens when you try to scale experimentation. You turn to a stack that's becomes a bit of a platform. So very quickly about me, you already heard the intro, so I'll go quickly over this. But a lot of what I learned about data science was at Airbnb early on, then Webflow.
Hey, Shay, sorry to interrupt, but I don't think your screen is sharing.
Oh, it's not? Okay.
Yeah, I'll go back in.
That is the thing to correct early on. There we go. Cool. Are we all shared? All right, I'm going to keep moving. So my formative career was at Airbnb and Webflow, and I learned a lot around how do you set up experimentation to scale at an org. This is what we're going to cover today, is first a bit of context around experimentation, why so many more people are talking about it and doing it now, and then we're going to dive into the meat of the talk, which is how do you actually set this stuff up. So as a starting point, when we first built experimentation at Airbnb back in 2013, 2014-ish, we had to do it on top of a lot of open source distributed computation frameworks like Hive and Pig. It was very complicated. We had to manage a lot of stuff ourselves. Now we live in the world of modern data stack, which I kind of define as this cloud warehouse-centric world with modeling layers on top to make really clean views for the rest of the org. And with that, companies are running experiments much, much earlier on. So I was most recently at Webflow. We were a Series A company, and we were running all these experiments. And the reasons you do it are pretty clear to anyone who's been part of these cultures. So if you've been at a place that has run a sufficient number of experiments, you quickly realize that all of these products you're putting out there that you think are great, only a fraction of them are actually helpful, like somewhere around 20, 30%. And that's been corroborated all over the place. So there's been papers out of Google, LinkedIn, Yahoo, Facebook, Airbnb, Netflix. Like it's very, very industry standard that around 20, 30% of these things they're launching are actually improving things at all. And another third are actually making it worse, which makes for a very big difference between, two companies competing and one knows what's helping, one doesn't. So the companies that realize this, like where I was at Airbnb, we build these really end-to-end experimentation systems, these experimentation stacks. And the funny thing about these is that underneath the hood, they all have exactly the same components. So these are all the components of what I call the modern experimentation stack. And so as a quick high-level view of it, on the two big inputs to it are one, the ability to randomize users into groups, and two, the ability to use a wide array of metrics. With these things together, you can calculate all the quantities you need to calculate. Those feed into your overall results, a bunch of diagnostics, and then a bunch of investigations. And then you have to serve it all with reporting. Now, I'm going to be going deep on each of these today to kind of figure out if you wanted to set up your own experimentation stack, what would you have to do? So to start with, let's talk with randomization. This is the thing that is mostly about experience delivery. How do you put people into groups? So the state of the art here, whether you're using third-party tools or you build it in-house, pretty much most of these systems look the same, which is that you have this SDK or library in your app. It is pulling from some experiment configuration server sometime every 15 minutes or maybe on every app open or whatever it is. You call some function that basically says, get me all the latest experiment information. This tells me what's currently going on, and then any kind of relevant information about it. And now all of your software engineers just kind of rely on this get variant, get variation, get treatment function that basically says for a given user an experiment, then tell me what group I'm in. Am I in group A or B? And under the hood, they all use these things called MD5 hashes, which is this thing where like you plug in some sort of string, and on the other end you get this value that you can put into buckets that you can randomize. And the key thing about MD5 hashes is that they're idempotent. If you put the same user through like 100 different times, they're going to get exactly the same response. And that's really key because you no longer have to store state. You don't have to store what assignment the user was in because the function will just always return the same thing. So this is the randomization piece. And especially once you get to experimentation, you really want to make sure you instrument this and say, what group was this user put in? So that's randomization. And then let's get into metrics. So on the metrics side, this is something I think is going to be near and dear to this audience's heart on the analytics side. I think the biggest gap that I see between how experimentation works at a place like an Airbnb and kind of what experimentation looks like at kind of most companies using an Optimizely or something like that is the Airbnb companies use business metrics for experimentation. Use things like purchases and revenue and activation. A kind of shorthand for how I think about this stuff is that if you showed this experiment report and it was moving this metric, would a business stakeholder, like would your CFO care? Would they actually be influenced by this? Because a lot of what you're trying to do here is like build coalitions and kind of drive a point of view that metrics should be a first-class citizen in product launch decisions. So the thing about a lot of these types of metrics, like purchases and activation, is that they tend to be modeled at the end of a DBT DAG or something like that. They tend to be in these cloud data warehouses and use a bunch of different sources like Stripe, et cetera. And in contrast, a lot of other systems might just use very upstream kind of click conversion stuff or data that is imperfect in some way. And the problem with experimentation is that imperfect data is pretty bad in this case because it's very much a precision game. You're talking about movements on the order of 2 or 3%. So you really, really need kind of your best quality data. And the other thing about these upstream metrics is that they can be deceiving. So as a case in point, we used to see this all the time at Airbnb. So if for people who don't know, at Airbnb, especially back in 2013, 2014, the way it'd work is you'd have to search for Airbnb listings. You would decide to contact one of them and say, hey, can I stay at your listing? And then this host would decide to accept. And then with that, you have a booking. And so there's this kind of funnel of agreeing to do this thing. Since then, it's been simplified with Instant Book, but there's still this funnel. And the thing that we kept seeing over and over is that an upstream metric might decrease or increase, and it would be completely undone by the downstream metric. And it would add up to basically a completely neutral experiment. And so over and over, we saw an experiment that would lift searches and drop, booking conversion rate or vice versa. So these experimentation platforms that can only use the upstream metrics end up missing a lot of the story if you can't tie it all the way down to the business metric down the line. So with these metrics and randomization, you then get into sufficient statistics, which is also known as what are the kind of aggregate amounts that are going to feed all the things you need to do. To do this is a big data engineering problem. And data engineering underneath experimentation are some of the kind of gnarlier problems you solve. To give you a sense of this, at Airbnb, the pipelines related to experimentation accounted for somewhere around a third of all computation costs. So it's a very, very hungry data pipeline, especially once you start scaling it out. And the funny thing about this data pipeline, this DAG, is that most of the action is in this top layer. So to give you a sense of what I mean, the DAG of every experimentation pipeline is take all the logs coming out of your randomization tool, take all the metrics in your library and join them, a big join. And then from there is 2 group bys. Once you have, here are all the metrics that apply to someone in an experiment, first you group it to an experiment subject level, and then you group it to an experiment level. Along the way, you can include user segmentations to do different split buys, say how does the experiment look on mobile versus web, whatever. But this is the general DAG, so it's a big join and 2 group buys. And most of the action in terms of computational cost and scaling problems and everything is in this big join. So as you kind of model out your platforms, you should really think about when are you incurring more of these joins at the top. Kind of moving on, we then get to the statistical tests. This is the part that is when experimentation ceases to be data engineering and it starts to become kind of science and statistics. And let's start with why do we even run statistical tests? One of the things I always think is interesting is when we're in the world of BI, you just make bar charts and you say one number is greater than the number, and you kind of live with that. So why in experimentation land do we use statistical tests? Well, a big part is every time you're doing those sums, like there's just a lot of variability that is built into the process, and you never really know, is this thing actually outperforming something else, or is it just dumb luck of where the wind was blowing on a given day? And so to give you a sense, like suppose you have some experiment and it has something like number of orders, and it looks like it's down by some amount, and this sort of thing would freak a lot of people out. They would consider the product potentially a failure. But once you actually model in the natural variation of this number, then you start to see that it's actually incredibly uncertain and it's probably just 0. It probably didn't change at all. So this is a lot of why we run statistical tests at all, is to say, is this a true effect or is this just a false positive? And with these statistical tests, there's basically 2 flavors that you have to decide between. And it's not really the 2 flavors I think most people expect. For people who have gone into the stats world, there's this whole frequentist Bayesian divide, which I'm not going to fully get into. Instead, I propose a different paradigm split. Do you use these things called fixed sample size tests or sequential methods? So fixed sample size tests are pretty much what most people use, especially when they're first getting started. It's these things called t-tests and z-tests. You may have covered them in high school or college. And also Bayesian methods also fall into this. The reason they're called fixed sample size tests is that these tests are designed to say, I am just going to wait 2 weeks and do something. Or I'm just going to wait until I get 50,000 users and I'm going to do something. And that's kind of the problem we have with these tests is that while they seem very simple to implement and you can use off-the-shelf math functions and matplot like scikit-learn and all that, it pushes a lot of expertise onto your org, because the caveat of these fixed sample size tests is that you're not supposed to look at the test until it's done. So if an experiment is going to take 2 weeks, you're not supposed to look at it until 2 weeks goes by. And once you are running stuff at an org level, once the kind of random IC engineers are running experiments and the growth team's running them and the payments team's running them, just getting adherence to that is very, very tough. In comparison, sequential methods, which are gaining a lot of steam, it's what we push a lot at EPO, they have a different thing where they're more complicated to implement. There's no kind of off-the-shelf math tools yet, and a lot of stuff is kind of in papers. But once you do it, it has this great benefit that you no longer have to worry about people peaking early and inflating their false positive rates. It's the sort of thing you can put into practice with all sorts of people with varying staff backgrounds and still get a good result. So to give you a bit of flavor here, this is a kind of typical experiment you might see at Airbnb, where you have this p-value threshold with a fixed sample size test, and just through natural variation, the test is naturally going to sometimes be significant. It's like a random walk in a certain way. And so if you hit here and you stopped and launched it, you would actually do the wrong decision. In comparison to the sequential method, instead of having a flat boundary, it has a curved boundary that says, early on, we're going to be a little bit stricter in terms of what triggers statistical significance. Continuing on, there's a lot of depth to these stat tests. And this is something that I think doesn't really get appreciated until you kind of platformize and really invest in these things. So for example, at EPO, we have this method called Cupid. And Cupid is cool because it solves probably the biggest pain points for for everyone running experiments, which is just waiting for data to gather. A very typical growth company might have to wait like a month for enough data to gather to call an experiment. But Cupid actually will take that 1 month experiment and make it run for 2 or 3 weeks, like a dramatic speed up. And it does it through this kind of interesting approach where it says, suppose you are McDonald's and you wanted to run an experiment to increase the number of Happy Meals. Well, the simple experiment would be like, go randomize a bunch of McDonald's franchises, have half of them do this new thing and see who sells more Happy Meals. But what Cupid does is it actually says, how about instead of randomizing franchises and just looking at Happy Meals, we also said, we're going to start making predictions whenever someone walks in the door around whether they're going to buy a Happy Meal. And then we're going to compare like how many more or less Happy Meals did you get compared to that prediction. And it turns out that this will speed up experiments dramatically because there's some pretty obvious things. For example, if someone walks in with 3 kids, then they're probably going to buy a Happy Meal. If instead it's like 2 hungover high schoolers, then maybe they won't buy a Happy Meal. Or suppose it's someone entering at the beginning of the day, then maybe they won't buy a Happy Meal because they're going to get a breakfast meal or something like that. So it turns out you can actually make some pretty good guesses. And the most strong guess of all is, have they purchased Happy Meals in the past 30 days? Because if so, they're probably going to continue purchasing Happy Meals. So what you do is you actually model this whole thing as a big linear regression. You can do kind of more in-depth approaches to this than the linear regression, but this is the way most people start out. Make a bunch of covariates and you run a regression, and then this actually will lead to results that converge much, much faster. So just wanted to show the Cupid thing just because it's an example of kind of the depth to statistics on experimentation. Continuing onwards, let's talk about diagnostics. So diagnostics are really, really important, and it's probably one of the biggest benefits you get once you consolidate around one platform. And a big part of this is that experimentation is built on this huge leap of faith that product teams are taking. I mean, it's experimentation when someone runs an experiment, there's a bit of a king-making aspect to it, where the people who have a bunch of successes are going to be thought of as performing well, and the people who have a bunch of non-effective experiments might eventually get questioned. So if people are going to engage in this kind of arena, they need to really trust that everything is above board. So by far and away, the biggest issue with experimentation diagnostics are sample ratio mismatch, is what it's called. It's the way it turns out is like, suppose you have some experiment, you think it's a 50-50 split, but it turns out it's not quite 50-50. Like it's 49%, 51%, which might seem innocuous. I bet if you do it by hand or if someone without a stats background does it, they're not going to blink. But whenever there's some kind of imbalance like this, it's always a canary in a coal mine, where maybe the people with the really low latency phones are not getting randomized properly, or maybe there's an issue on a certain device or SKU or something. There's always some sort of bias to it. So you want a platform that can automatically tell you when there's an imbalance, and there's a statistical test for that. You run a chi-square test to do it, or there's kind of even more sequential versions of that as well. So first thing, always know if you are having a traffic imbalance. The second thing, and this is also pretty rampant at every single place I've been, whether Airbnb, Webflow, or what else. Like, it turns out in the real world, there are a lot of outliers. For anyone who has read the Nassim Taleb book, The Black Swan, it is completely true that in the world of highly networked kind of social problems, you end up with these things called power laws, where, like, in the world of physics, and you think of your bell curve, your normal distribution, you have these distributions that kind of go to zero pretty quickly. And instead, power laws just have what you call fat tail, where it's just much, much, much more likely to get outliers. So examples of this were at Airbnb, we had these hosts we called whale hosts. They were not your mom and pop shop, like running an extra room in an Airbnb. They were a large corporation with thousands of Airbnb listings all over the place. And it turns out if these whale hosts were not properly randomized, they will actually drive the whole experiment. And so an experiment that seems like it's successful just lucked out and got a few more whale hosts. A similar thing happened at Webflow, where there were certain site creators who created thousands of websites because they were doing it at a corporation at scale. So these outliers, they come up all the time. There's a few approaches to think about it. You can use non-parametric tests. That doesn't happen too often, but what we do at EPO, we Windsorize the results. So it basically says, take any distribution, say like revenue or purchases, whatever, and just cap the values at the 99th percentile. That tends to cut off these kind of very, very large fat tails. And then Cupid, which we just mentioned, part of the benefit of Cupid is that subjects that are outliers were probably outliers before the experiment even started. They probably have always been these outliers. And so being able to use pre-experiment data to denoise the signal with Cupid turns out does a lot for outliers. Other things, and I'm sure this part will be very familiar to everyone in this audience, but when you use warehouse data, you are beholden to the quality of the data in your warehouse. So I remember Airbnb throughout our lifetime, there would just be moments when the pipelines weren't being updated or there was some error. And what we saw is that these PMs, the second they don't see an experiment that matches what they expect, the first scapegoat is always the warehouse. It's always like, is this data clean, is up to date? So you have to do something to make those sort of problems visible at the report level, because, suppose you just look at these confidence intervals in these results and it has like a 0.5% lift. Well, the data could be equally broken on both control and treatment. And so if you use the treatment over control, then it's, might become invisible. So usually you need some sort of alert, some sort of anomaly detection, something to say like, if the data looks like this, then maybe you shouldn't read this report right now. It's time to go talk to your neighborhood data engineer. So that was diagnostics. Again, people put a lot of trust into experiments, so you have to make sure that they always know when something is ready to read. The last part is investigations, and this comes out of something that we saw all the time, which is that you never just run a test and move on. You always want to learn more around what is driving that experiment. And I thought a quote that really drove this home was Elena Verna, who's kind of a Reforge ERR growth leader. She had this quote around experimentation practices, which is, first you have to learn to test, then you have to learn, and then you can learn to win. And what we mean by that is, first you have to learn to test, in that you have to be able to run an experiment at all. And so that's where a lot of this talk comes in around setting up randomization, setting up metrics. The second thing you have to do is learn to learn, because a lot of your first experiments are probably going to fail. They're probably going to be neutral or negative or not drive the metrics you want. The success rates of 20-30%, and then add on to that a bunch of just probably likely execution errors. And so what you need to do is quickly figure out, why did this experiment not work, or why did it succeed? And once you know these sort of drivers, every time you touch this one part of the UX, the customers hate it, they really like that part. Or every time you push something below the fold, it actually will affect it. Once you know all of these little gotchas, these minefields, then you can start reliably kind of delivering wins where you actually will drive these metrics. Now, to do that, to give you a sense of what I mean, take at Airbnb. We would see all the time these experiments that would look overall neutral, but if you examine it by some segmentations like browser in this case, you saw that it was actually a pretty good experiment. It just had an IE bug. There was a bug on Internet Explorer. And so when you trace that down, it's like, okay, now we can fix it and actually have a viable experiment. We saw a similar thing at Airbnb with regions, where an experiment would look negative, but it actually was just a broken time zone, and East Asia had dipping metrics. And then at Webflow, we saw all the time that we'd run these experiments, and we had these two user segmentations. One were these non-technical business owners, and the other was technical designers. And they just wanted wholly separate things. The business owners wanted Webflow to look like Squarespace. They wanted to be very simple, very easy to use, but limited. Whereas the designers wanted something that looked like Photoshop, full of powers and widgets and all sorts of things, but they were willing to deal with the learning curve. And so being able to cut by different user segmentations will help you understand, maybe this experiment did work overall, but did someone like it? or did someone hate it? Is there something I can take into the next experiment? So the best platforms, whether at Airbnb or Netflix or whatever, everyone makes these segmentations really easy, both to add segmentations and to slice experiments by them. So then we get into reporting. And the thing about reporting is I'm always astounded by how inscrutable experiment reports are for a lot of practices. Like I just Googled experiment reports, like, high quality experiment reports, and came up with these images. And I cannot imagine a non-technical PM actually, reading these things with confidence. So there's a lot of benefit if you can just consolidate experiment reports into something more approachable, something that feels more native to an org. Because the alternative is that you're going to need the author of these dashboards to actually read it out loud every time. So at EPO, we take a bit of an opinion that in all of these sort of statistical concepts and kind of need to knows about the warehouse should probably be abstracted away from the report and kind of only be handled by the technical users. So, one of the things I always joke is that if in the world of explaining to people what a p-value is coming out of a t-test, then you're probably going to lose the room. Even among this crowd, I would wonder how many people could confidently say like what a p-value was. So instead, lean on abstractions, things like confidence intervals, or people understand that this is a big, wide, uncertain thing and this is a narrow, certain thing. Or instead of doing things like a power analysis, you can just give a progress bar and say like, what % done is it? All in all, just be opinionated and make it really consistent so that when a product leader reads an experiment from the growth team, then reads an experiment from the ML team, they don't have to relearn a bunch of UI. They can actually have some consistency. And all this kind of feeds into, I think, what most people aspire to with experimentation is to build a culture of it. I always say that experimentation is cool, not just because it has this tangible benefit on revenue and ROI, but it also just unlocks this entrepreneurial culture of like trying out ideas, letting people put stuff out there without having to win political debates, without having to have the charisma to sway the head of product. You can just put something out there and just see what the customers think. So that's kind of where you end up with. And I think if you've been part of a company that has really embraced experimentation, you can tell it kind of feels different in how empowering it is. So I think kind of embracing this sort of platformized modern experimentation stack that does everything with rigor, with diagnostics, and is approachable on a single player mode by some IC engineer, that's kind of really how you start driving the culture. So with that, I'll kind of wrap it up and kind of open up for questions. I wanted to speed through a lot of the content and see what people want to know. So we've got a couple on the side here. I'll start with those and just keep adding them to the Q&A panel if you want any more. Let's see. Set number of go-to statistical tests for data sets. Yeah, so there's the basic thing about statistical tests is that you might use a different one depending on the type of metric. So, for example, it turns out you should use a different statistical test if you're doing a continuous variable than a binary. Like a binary, did you upgrade or not? Versus continuous, like how much revenue do you have? It's the sort of thing that a platform should abstract away from people. Like most people aren't equipped to make that choice. Basically, you should just detect what type of metric you're dealing with and use the appropriate one. Another example is if you do a ratio. So something like average purchase price, like take all of the purchases happening and what is the average price of them. That, it turns out you have to use something called the delta method, which is fairly complicated. And again, something that should just be abstracted away into the platform. In terms of learning about them, I will admit that in today's world, there's not a great consolidated set of knowledge. There's a bunch of disparate blog posts and statistical guidelines. There's college classes that will give out their slides. We're going to be putting out a lot of educational content to try to bridge this gap. So there's one consolidated place to see, like, I don't want to just read a blog post about Bayesian methods. I want to understand how they compare to sequential and to t-tests and what are all these words and how should I think about them. So we're going to be making efforts to consolidate that, but I can't think of any off the top of my head that have that available.
Right. I am here to wrestle a session back from you, Jay. But we have a couple questions left that I will carry over into the OA Club Slack so that folks can follow up with you there. But yeah, thank you so much for your time and for your presentation. This was super informative, and I'm sure folks will reference a lot of what you've been talking about. But yeah, is there any other nuggets of wisdom, anything like that you would like to leave folks with before we say goodbye?
No, thanks for having me on. These questions are great. I hope to get to them in the Slack after.
Awesome. We appreciate it. Thank you so much. And we'll be back in a couple minutes with Gabby Steele.
Yep. Bye.